My dear students, in our previous lecture, we have learned about preparation of alkanes from unsaturated hydrocarbons and from alkyl halides. Today, continuing with that, in part 2, we shall learn about preparation of alkanes from carboxylic acids. Sodium salts of carboxylic acids on heating with soda lime. Soda lime means a mixture of sodium hydroxide and calcium oxide. When we heat sodium salt of carboxylic acid with soda lime, they give alkanes with one carbon atom less than the carboxylic acid, and carbon dioxide is eliminated. This process of elimination of carbon dioxide from carboxylic acid is called decarboxylation. So, in other words, we can say by decarboxylation of carboxylic acid salts, we get alkanes with one carbon atom less than the carboxylic acid. Let's see an example. CH3COO-Na. This can be written as CH3COO minus Na plus. This is because this is a salt. Salt will always dissociate into ions. Though this is sodium acetate, which will be dissociated into acetate ion and sodium ion. This will combine with sodium hydroxide in presence of calcium oxide on heating will give CH4, that is methane and sodium carbonate. This sodium carbonate will dissociate into sodium oxide and CO2. This is carbon dioxide. This is elimination of carbon dioxide. Sodium acetate's molecular formula is C2H3O2Na. So, when this reacts with sodium hydroxide in presence of calcium carbonate on heating will give CH4. There are two carbon atoms here. There is one carbon atom here. So, as we said earlier, this gives an alkane with one carbon atom less than the carboxylic acid. This carboxylic acid has two carbon atoms here. This alkane has only one carbon atom here. So, this is how it happens. Let us see about sodium propionate. Sodium propionate is C2H5COO minus Na plus. This upon treatment with soda lime, this COO Na will combine with NaO of sodium hydroxide to give sodium carbonate and ethane. So, the molecular formula of sodium propionate is C3H5O2Na and ethane has C2H6. So, here the carboxylic acid has 3 carbon atoms, whereas ethane has 2 carbon atoms. So, 1 carbon atom less than the carboxylic acid salt. Similarly, to prepare propane, we take butanoic acid sodium salt, that is sodium butanoate. Sodium butanoate has C3H7COO minus Na plus NaOH in presence of calcium oxide on heating gives propane C3H8 and sodium carbonate. This sodium carbonate will dissociate into sodium oxide and carbon dioxide. This is the elimination of carbon dioxide. So the molecular formula of sodium propionate is C4H7O2Na. So there are 4 carbon atoms here, whereas propane has 3 carbon atoms. One carbon atom less than the carboxylic acid salt. This is propane. Similarly, to prepare butane, we take pentanoate, sodium pentanoate, that is C4H9COO minus Na plus with NaOH in presence of calcium oxide. On heating gives butane C4H10 and sodium carbonate. Sodium pentanoate has C5, molecular formula is C5H9CO2Na. This upon reaction with sodium hydroxide in presence of calcium carbonate gives C4H10. This is butane. Here the carboxylic acid salt has 5 carbon atoms. Butane has 4 carbon atoms, 1 carbon atom less. And sodium carbonate dissociates into sodium oxide and carbon dioxide. So this is decarboxylation reaction. This we can easily write like this. CCC, hydrogen atoms to fulfill 4 valence of carbon. So here 3 hydrogen atoms, 2 hydrogen atoms, 2 hydrogen atoms, 2 hydrogen atoms. The remaining place is occupied by COO minus Na plus. This is sodium pentanoate. This upon treatment with soda lime, this will combine, COO and Na will combine with NaO to give sodium carbonate and butane. This is CCC4Cs and 3 carbon atoms on first carbon, 2 carbon atoms second, 3 carbon atoms on third, 2 carbon atoms on third carbon, 3 carbon atoms on fourth carbon. This is butane. So C5H9CO2Na becomes C4H10, that is butane, 1 carbon atom less than the carboxylic acid salt. Now let us see another method with carboxylic acid salt to prepare alkanes. This is kolbes electrolytic method. An aqueous solution of sodium salt of carboxylic acid or potassium salt of carboxylic acid on electrolysis gives alkane containing even number of carbon atoms. Even number means 2, 4, 6, 8, etc. at the anode. So an aqueous solution means sodium salt of carboxylic acid CH3COO Na plus. This is sodium acetate or sodium ethanoate. Aqueous solution means we add water to it. 2 sodium acetate moles and 2 moles of water on electrolysis will give C2H6. This is ethane. This is an even number of carbon atoms in alkane because 2 carbon atoms are there. 2 carbon dioxide moles, 2 NaOH, H2O gas. This is the total reaction. Now let's see the reaction path. First of all, the sodium acetate is split into sodium acetate salt is split into acetate ion and sodium ion. This is a reversible process. 2CH3COO minus Na plus is split into 2CH3 C double bond O minus, that is sodium acetate ion, and sodium plus ion. What happens at anode? At anode, this acetate ion CH3COO O minus is acetate ion. This oxygen atom has 6 electrons in its outermost orbit after donating 1 electron for this bond between carbon and oxygen. Why 6 electrons? Because it has gained an electron from the sodium ion. So, there are 6 electrons. 2 moles of acetate ion will give off 2 electrons at the anode, and it becomes CH3 C double bond O oxygen with 5 electrons. This is called acetate free radical because there is an unpaired electron on this oxygen atom. This is acetate free radical. In the same step, the bond between CH3 and this C will cleave homolytically. That is, homolytically means each electron of this bond, 1 electron will go to carbon, 1 electron will go to this carbon. As a result of which, we get 2 methyl free radicals, CH3 radical, because there is one unpaired electron on this carbon. So this is methyl free radical. And this C double bond O oxygen will combine this free radical and a free radical formed on this carbon will combine to form another bond here. So this becomes carbon dioxide. So 2 moles of carbon dioxide are eliminated. This happens at the anode. At the anode only, these 2 methyl free radicals formed will join to form a bond between them. So this becomes ethane, CH3 single bond CH3, ethane, or this can be written as C2H6. This is ethane is formed. And at cathode, hydrogen molecule will take 1 electron from the 2 electrons released here. At the anode, it will take that electron at the cathode to become OH minus ion and hydrogen free radical. This is how it occurs. Water can be written as H single bond OH. One of these OH bonds will split homolytically. 1 electron goes onto the oxygen, another electron goes onto the hydrogen. As a result, we get hydrogen free radical and we get oxygen free radical. This oxygen free radical will combine with this electron to become OH minus. So these hydrogen free radicals formed will form a bond between them and become hydrogen molecule. This escapes as hydrogen gas. So at cathode we get hydrogen gas and at anode we get ethane gas. So both are gases, and carbon dioxide gas is also liberated at anode. So at anode we get carbon dioxide gas and ethane gas, and at cathode we get hydrogen gas. This process is called kolbes electrolytic method. In this we take sodium or potassium salt of carboxylic acid and we get an alkane with even number of carbon atoms at anode along with carbon dioxide, and at cathode we get hydrogen gas. This is called kolbes electrolysis. This is how alkanes are prepared from carboxylic acids. Thank you very much for watching. Please like, share and subscribe. Thanks.